Hello everyone and welcome back. In this video, we're just going to be doing a few examples of the product rule, okay, for derivatives. So let's do it, right? So let's say we have something like this. We have some function, and let me not do that. Okay, let's do this instead. Here we go. So the first thing here, when you're taking a derivative, is to understand the form of the expression. So in other words, it's important to realize that this is multiplication between x squared and cosine. So that means this is a product. And anytime we take the derivative of a product, we have to use the product rule. And I'll write that down now. So the product rule says that if you take the derivative of a function that is actually two functions being multiplied, that we're gonna have the derivative of the first one times the second one plus the first one with no derivative times the derivative of the second one. Okay, so there's the product rule. So in this particular example, let's identify f and g. In this example, f of x is x squared, g of x is cosine x. Once we have this, we need the derivatives of each of these pieces. So the derivative of x squared, that's power rule. So we're going to take the power, bring it down, reduce by 1, we get 2x. And then the derivative of cosine, sort of stated it, is negative sine. And these are the derivatives of the trig functions, the power rule. These are just things that we have to have memorized. We need to know them immediately. Okay? So we have every piece. So now we can write down the derivative of the product. And I'm just going to plug it right into this formula here. So the derivative of f is 2x. G with no derivative is cosine. Plus f with no derivative, so x squared. And then the derivative of g, so negative sine. Sorry about the jumbled mess there. And now I'm just going to sort of clean up anything that I can and write it in a way that's a little more cohesive. 2x cosine x. And then we have a plus and then a negative here. So this is going to be actually a minus x squared sine x. Okay? So this is perfectly fine. You may also see something like this. Both of these terms have a greatest common factor of x. So you may see this in a multiple choice situation. Okay. Both of these are correct. One is a factored form and one is not. Okay, so there's a product rule example. Let's look at this. Let's say we have something like this. X squared square root of x. There's actually two ways we can do this. And the first way is what this video is about, is the product rule, right? So the first piece of the product, let's see, I'm using g of x there. So I guess what I'll do is I'll write P1 for piece 1. Piece 1 is x squared, and piece 2 is the square root of x, which is the same thing as x to the 1/2 power. Okay? Awesome. And again, we know the product rule. We should memorize the product rule as well. So, it's up there on the screen. But I'm going to do this one without actually having the product rule on the screen. So we need each derivative. So the derivative of piece 1 is 2x. The derivative of piece 2, power rule, right? 1/2 x to the power negative 1/2. And we can write that this way, 1 over 2 x to the 1/2. And then once again we can rewrite 1 over 2 square root x. There we go. Okay. So if we do the whole thing now, we want piece 1 with a derivative, so 2x. Piece 2 with no derivative, so that's x to the 1/2. Plus piece 1 with no derivative, and then piece 2 with a derivative, so times 1 over 2 square root x. Okay? And now it's just algebra time, yeah? So this is like 2x to the 1 times x to the 1/2. We can just add those exponents. And then plus, this will be x squared over 2 square root x, or x squared over 2 x to the 1/2. Here we're multiplying, the base is the same, the base is x in both cases. So we add the powers. 1 plus 1/2 is 3/2. We get 2x to the power of 3/2 plus, so now I'm going to rewrite this way. So here, we are dividing 2 powers of x, so we need to subtract those exponents. So 2x to the 3/2 plus, and then this is going to be x to the 2 minus 1/2. We're subtracting the exponents, and then don't forget to divide by the 2 there. Okay? And so this is going to be 2x to the 3/2 plus x to the, and then 2 minus 1/2 is 3/2 as well. All right, cool. So now, these are actually like terms. They're both x to the 3/2. We just have 2 terms with a different denominator, so we need to get a least common denominator, and that least common denominator is simply going to be 2. Okay? Term number 1 is missing a factor of 2 in its denominator. The denominator of term 1 is 1. 1 times 2 is 2, so we multiply top and bottom of the first term by 2. And so we wind up with 2 times 2 is 4, x to the 3/2 plus x to the 3/2, and now all that is over 2. And then these are like terms. We can combine these. 4x to the 3/2 plus x to the 3/2 is 5. X to the 3/2 over 2. And we can write that this way. 5. And then 3/2. That's the square root of x cubed over 2. Okay? And then we can simplify the square root as well. In the following way, basically, the square root of x cubed is the square root of x squared times x. And the square root of x squared technically is absolute value of x times the square root of x. However, because of this, x cannot be negative, okay? X has to be bigger than or equal to 0. Because if x were negative, we would have a negative under the square root, which would give us a complex number or imaginary number. And in calculus, we are working only with real numbers. So because x has to be greater than 0, we can actually remove absolute value from the x there. And we can write this as x squared of x. And so again, this is another way to write the final answer. Okay? Now, in the beginning I said we could do this a different way. And so let's talk about that. I feel like what we're getting ready to do is actually going to be easier overall. It just requires a little bit more work on the front end. So we can use the product rule like we did here, or we can do some algebra with this first. Here's what I'm talking about. So the function in question was x squared, square root of x. And what we can do is we can simplify this ahead of time. Square root of x is x to the 1/2, so this becomes x to the 2 plus 1/2. And then, 2 plus 1/2 is 5/2. And now, this derivative becomes much easier. Because all we have to do now is just apply the product rule, not the power rule, x to the 5/2 minus 1. So we get 5 over 2, x to the, and then 5/2 minus 1, that's 5/2 minus 2/2. Which is 5 over 2, x to the power. 5 minus 2 is 3. And once again, we can do that. We can play this game. And just like before, we can do that. 5/2 x square root x. 5/2 x square root x. Yeah, so in this case, this situation, the second way that we did it is way easier. So, this is another thing that you want to think about is, what is the most efficient way to take the derivative? A lot of times there's more than one way to approach these problems. So, it can be good to think about which way is going to be the simplest, because the more complicated, the more steps. The more steps there are, the more likely you are to make a mistake. All right. How long have we been going? 12 minutes? Yeah, we'll call it.